Hi, this is Mr. Max. I gave a worksheet on mensuration that deals with area, volume, um, and these type of things. Of course, this can be used by so many different grades. So in this particular 12-page document, you will be calculating the perimeter and area of a trapezium and a kite. You'll be asked to calculate the area of a circle using the formula. So remember, the formula for calculating the area of a circle is pi r squared. Then you also have to find the diameter or radius of a circle when the area is given. Calculate the surface area of cubes, cuboids, rectangular cuboids. Cuboids are also known as rectangular prisms and closed cylinders. Calculate the volume of closed cylinders. Of course, the formula to calculate the volume of a cylinder would be pi r squared times the height obviously being given, or you will be given one or the other. Okay. Then you have the volume. You must find unknown dimensions or measurements of cylinders if either you are given the volume and other information is given. Right. So let's start with question one. As I said, quite many. So they ask you, the diagram shows a circle, as you can see here, and the radius of the circle is represented by center O. Line AB is 14 centimeters, and the question is asking you state the special name of line AB. So of course, line AB is nothing but the diameter. Right, this is not the value of pi. Pi itself is an irrational number. Okay, so if you were to find the value of pi, you'd see that it is a number that doesn't really stop and it cannot be written as a fraction. And because of that, you know, at times at levels like this, they will give you an estimate to work out the circumference. Now, the circumference, again, in this particular, it is the distance that you have, as I'm indicating, that distance over there, that is known as circumference. Okay, so the circumference is then calculated by using C. We can say it's 2 pi r. Now 2r, that is like twice the radius, so it can be like the diameter. Okay, 2 pi r, 2 pi r, that is the formula. Okay, or you can say, well, 2 times the radius, that's the diameter times pi. So this is the formula that you can use to find the circumference. So in this case, the circumference will be 2 times, well, pi times, they're saying, of course, they're saying for pi you must use 22/7, so you can just go ahead and use 22/7 for pi. So that is 22 upon 7. And of course, the radius, if you now have the radius is half of that, and the radius is 7. Okay, if I was using this formula, I would be using obviously the diameter of 14. So radius is that. So of course, if you see that you can cancel out, and then this answer here will be 44 centimeters only. Of course, you get the same answer if you were to use the formula that I have listed below here. You can say circumference is diameter which is 14, and the radius is 22/7. Well, of course, you can grab your calculator also. This goes in itself once, goes there 2 times, 2 times 22. Yes, you still get the same answer as indicated. Right, let's go to the second question. The diagram shows a right angle triangle. The area of the triangle is given as 30 square centimeters. Calculate the height. Now, what you need to know is the area of a triangle is a half times the base times the height. So a half times the base can be 12. The height is what we don't know, but we are given that the area is equal to 30. So you can actually go half of that is 6h is equal to 30. And then you can calculate the height and say, okay, wait, the height will be 30 divided by 6, which is 5 centimeters. Okay, just using the formula and substituting and finding the unknown. Right, you have got the kite here. They say find the area of the kite. Now the formula to calculate the area of a kite you're going to multiply the diagonals with each other. So you say diagonal 1 times diagonal 2, and you're going to find half of it. So you're going to say 6 times 8, and then you're going to divide that answer by 2. Okay, so the diagonal here will be 24 square centimeters. I mean the area of that kite. When you come to question 4, calculate the area of the circle with radius. Then they are saying we are supposed to use 22 over 7 again. The formula to calculate the area is pi, which in this case is 22 over 7, times the radius. The radius is 21 squared. So the formula to calculate the area of a circle, the area of a circle is pi times r squared. Of course, you can actually go ahead and 21, they are saying the radius of the circle is 21 centimeters, and that is the value. So I'll just go ahead and grab a calculator. Don't make your life difficult. Of course, I can calculate that without using one, but such questions, in order to avoid your accuracy issue, you get 1,386, so 1,386. So that being 1,386, that will be the area of this circle. So what we have over here is effectively known as a trapezium or trapezoid, depending which country in the world you are. Of course, the formula to calculate the area of a trapezium is you're going to take side A plus side B. This is the sum of the parallel sides. So in this case, my A can be 5 and my B can be 12. Okay, and we're going to divide this by 2. And at the same time, we're going to multiply it by the height. The height is the 6 here. Right, so this is the way you're going to find that. Okay, we're going to use this in part B. So the name is the trapezium. Right, let's calculate the area again. As I said, I've started. So I've got 5 plus 12, which is 17. So you have got 5 plus 12 times 6, half of that. Of course, finding the area. Can I say, well, this 3 goes in itself once. It goes there. I mean, this 2 goes once. It goes there 3 times. So you're going to have 17 times 3. Okay. And then 17 times 3 is 30 plus 21. So, of course, you have got 51 square. Now, where I get 30 plus 21, I'm saying effectively, I'm dividing this 17 in 10 plus 7. And 7 times 10 is 30. And 7 times 3 is 21. Right. The next question, you have got a bunch of shapes here. You have a circle, you have a trapezium, you have a cylinder over here, you have a rectangular prism, also known as a cuboid. So part A, they say calculate the circumference of shape A. Now shape A, again, there are 2 formula. Circumference is going to be 2 pi r. I'm going to use this one because, and of course they are saying that for pi, whenever we're dealing with circular things, we're going to use 22 over 7. Right, so that implies that the circumference will be 2 times the 22 over 7, and then the radius here is also 7. Of course, this is like what we had before. The answer is just 44. Of course, that if you know, you know. Yeah, 7 and 7 cancel. 2 times 22 is 44. Area of B, again, said as a B, this is like a revision stuff. B is a trapezium, you take the sum of the parallel sides, you multiply that by the height. You have to be very careful. So the other distances are just given to you as a decoy. The height is 5, where it makes 90 degrees with one of the sides there. And you're going to obviously divide that by 2. This is the formula that you're going to get. Okay, so 3 plus 8 is 11. 11 times 50 times 5 rather. That gives you 55 halves. Okay, and you can actually leave your answer like that, or you can say, well, a minute, you can leave it as 27 and a half. It's totally up to you. So this is 27 and a half. 27.5 will also do. Shape D. When you look at shape D, of course, that is a cuboid. Okay, and the volume is simply multiplying the dimensions of each other, length times breadth times height. Okay, so if you are asked to find the volume of shape D, you're going to multiply those dimensions of each other. Right, so the volume is 13 centimeters times 4 centimeters times 7 centimeters. Of course, everything here would be cube. So make sure that our measurements are as indicated. Right. So you can just grab your calculator. You say, okay, well, a minute, that's 13 times 28, 28 being 4 times 7, okay, 364. And then the correct answer here is 364. Now, I know I might look like I'm rushing through the stuff. I gave this, so I expected the learners to be working them out. This officially becomes the answers, and then they can just compare and see. Of course, you also have the liberty of pausing and so on. Okay, shape D. Now, you're told shape D has a volume, and then you're supposed to write this in liters. Now, here's what we need to know. 1,000 cubic centimeter is equal to 1,000 milliliter, which is equal to 1 liter. So you are going to take 6,333.5 and you are going to effectively divide that by 1,000. So the point being here, and that would be 6.3335 liters. Of course, you can leave your answer like that. So I'm just going to leave it like that, 6.335 liters. So again, it's very important that you take note of this fact, and I expect you at this level to have done a few examples on that for you to be able to know that conversion. Right, is there anything? Okay, so they're bringing us to the next question. So they're saying that this is a cuboid, or a cube rather. So this side is equal to this side is equal to that side. So it's side times side times side gives you a volume of 125. So in order for you to get that side, you'll be taking the cube root of 125, which is 5 centimeters. That would be 5 times 5 times 5. Right, the diagram shows a cylinder. Now, of course, they want you to, diagram 1 shows a cylinder, diagram 2 shows a triangular prism. Now, you are supposed to complete the net. So, in this case, the only thing that really was supposed to be is just like a rectangle, like so. Okay, right. So, in this other one, of course, I'm just going to draw that. So I'm going to use a ruler, and of course it's supposed to be like, okay, it's like it's not according to scale, but I think you get the idea, right? So the other one is slightly shorter than the other one, but I think you get the idea. Okay, so let's see if I can just I think that's a little better. Okay, so those are the nets. So if you were to obviously fold it, it just becomes the cylinder as required. And of course, now you have, if you were to bring these triangles up, and the other two will just fold nicely and easy on it. Okay. If you look at the base here, this base, this one here that I'm noting in yellow, that base over there, of course that is going to be this particular part. Right. Good. Next question. Question 9, they're saying the volume of a cylindrical water container when it's completely full is 200,200 cubic centimeters. The water container has a radius of 35 centimeters, and then they say for pi, you continue to use 22.7. Now it's supposed to find the height. So the volume of a cylinder will be pi r squared times the height. So we know that pi is 22/7. We know the radius is 35 squared, and you can just see interesting thing that this 35 and 7, obviously they are going to be multiples of each other. Okay, 35 is a multiple of 7, and we need to find the height. So we need to find the height, and the volume is given to you as 200,200. Okay, good. So on the left side, let's just clean up the left side. Okay, so let's see. We have 22/7. Then we're going to multiply that by 35 squared. What do we get? 3,850. Okay, effectively, this is going to give you 3,850 H equals to 200,200. So our H will be that 200,200, divide that by 3,800. Of course, that was 3,850. 3,850. Okay, so let's get up the calculator. So we're going to say 200, 200. We're going to divide it by our answer. Because it's 52. So the height is 52 centimeters. That is going to be the height over there, 52 centimeters. Right, let's get to part B. They say this is a nursery school. They build a square base cuboid. So if this is 3, then obviously this is also 3 meters over here. Okay, very important to complete the diagram to see that what is it that you need to ask to be solving rather. They say find the volume of the cuboid. So the volume will be 3 meters times 3 meters times 8 meters. Of course, that meter is going to be cubed. All right, we'll just save here because I've learned my lesson when it came to this software. 3 times 3 is 9, 9 times 2, 9 times 8. Of course, 9 times 8 is 72. Now, of course, they are asking for volume, so this problem here is a problem. It's supposed to be cubic centimeters. Okay, but, oh, maybe it's the next question. Let's see. Question 10. You have a cylindrical tank with radius of 35. They seems to be liking this radius of 35. They say it's filled with water to a depth of 44 centimeters. Calculate the area of the base. Now, the formula to calculate the base is just pi r squared because the base is a circle. Then we're probably going to use 22 over 7 since it has been, through and through what we've been using consistently. So we're going to continue with that. So it's going to be 22 over 7 times 35 squared. Now, why do I think that we have done this one before? Let's see. 22 over 7 times 35. Of course, we've got 3,850. Right, no need to calculate it again, but you can if you want to. So that is 3,850. That will be the area of the base there. Okay, you can just grab your calculator again. You can say 22 upon 7, multiply that by 35 squared, which gives us that. Okay, now the volume, we need to calculate the volume of water in the tank. So the volume of the water in the tank, the formula is V equals to pi r squared, which we have, times the height. So the area that we got in part A, we are going to say 3,850, but the height that we have, because we are calculating that's going to represent our height. Okay, so we're just going to multiply our answer by 44. It's 169,400, so it's 169,400. All right, so don't just clear your calculator display, always know that you might be using it. Now we have done something similar where we changed something in cubic centimeters to liters, so we're just simply going to divide by 1,000. So just refer back to this particular, I even highlighted that for you to know when you're changing this particular one here at D, when you're changing cubic centimeters to milliliters to liters. Okay, so we're going to be dividing that answer over there by 1,000, and the comma just moved 3 places, so 169.4 liters. So that will be 169.4 liters. Good. Question 11, a little bit spicy. They say the diagram shows a cylindrical tablet container with a diameter of 4. Okay, so it's important to work out the radius. The radius will just be 2 of this one over here. Very important. Then the height is 10 centimeters. Calculate the volume of one cylindrical container. So the volume of one will be pi r squared times the height. So in this case, pi is going to be 22 over 7. The radius that we have is 2 squared times the height, which is 10. Of course, we're going to continue using 22 over 7 because you can use other values. Now, we're going to look and say that is 22 upon 7. Multiply 2 squared is 4. 4 times 10 is 40. So we just multiply that by 40. Okay, we're going to get a horrible number, Of course, I'm just going to give my numbers 125 and 5 over 7. So that's 125 and 5 over 7. There's that recurring issue. You can also then give a rounded answer. The cylindrical containers, now I'm leaving this because I most probably know that there is going to be parts that we're going to use. Okay, they're saying the cylindrical containers. So let's just see if we can grab, snapshot this, just bring it down here. Anywhere will do for now. I'll just put it over here so I can see. They're saying the cylindrical containers, they are packed into a box, and the box is in the shape of a cuboid, as you can see. The box is 48 centimeters long, 24 centimeters wide, and 10 centimeters high. How many of these cylindrical containers can be packed inside the box? Now, there are many ways you can look at this. Of course, these things will have a um, consistent, the height, there's nothing you can do. Something I need you to realize. The height of this is the same as the height of that. So what I'm doing now has got nothing to do with that because they will stand upright. So I will say, wait a minute, I can see that the diameter is 4. Okay, the diameter of this thing here is 4. I'm going to divide that 4 into both of this for me to be able to see. But now, if one was to grab one, okay, if one was to grab one, let's see, uh, let's see if we can bring it back. Okay, if one was to grab one, and most probably, if I was to think of this one, okay, let's just see if we can take a snapshot of the point I want to make. If you take one of these and you were to put it inside here, now it's going to have a thickness this way, the length, and let's say we bring another one just to express my point. Now, this over here, if I go grab this over here, is said to be 4 centimeters. So if I was to say, okay, wait a minute, how many of them will be like in front here, the length? That will be like 48 divided by 4. Of course, that will give me 12. Okay, so 12 of them will be here. But now, that thing has also the same time. So if I was to move this, and let's say, okay, let's see, we'll paste. If we put one here at the corner, okay, if we put one at the corner, now it doesn't come out the way I want to, but the point I want to make is that it's going to have a thickness there as well in this direction of 2. So if you take 24 and you divide that by 2, okay, 24 divided by the 2, you get half of 24, which is what? Which also not is divided by 4 rather, not by 2, by 4. Okay, we divide by 4 because the width of this is 4. You get 6 that are going to be there. So effectively you have 12. You have got 6 there that you can fit in, but you must be a bit careful when you are saying you can fit in 6 there. So it's going to be 6 of them, but that one will take, a shape. So we're going to use this 12 and this 6. So if I was to say to you that the answer to this, and I will come back to this, is 12 times 6, which you can say, okay, well, it's 72 of them. It might be a bit of a problem. Let's see what will the other approach will be. Now, let's say, what is the volume of this box, the container? So the volume of this, which is what we're going to do in part C. Okay, I don't want to show part C now. Okay, because they're talking about surface area. There is a part here, the volume of the box. Let's see if I can remove all of this and just move them. Okay, that's what I was thinking. I'm going to leave it for now like that. In terms of the volume of the box, I'm just going to calculate the volume of the box here. just to explain the point that I want to make. The volume is calculated by multiplying the dimensions with each other. So you'll be multiplying 48 centimeters times 24 centimeters times 10 centimeters. Of course, all of this should be in cubic centimeters. So when I say 48 times 24 times 10, that gives me 11,520. 11,520. Now we know that one cylindrical container has got this. So if I was to take that and I divide it with the volume of one container, cylindrical container, which I'm just going to go back and calculate 22 over 7, just because it was a recurring decimal, times 40. When I divide that, that is going to tell me exactly, okay, you see, I have got about 91. So you have got about 91 according to that, because the volume of one cylindrical container is about 91.6 and so on. So effectively, we need to be able to fit in 91 of them in there. But if you look at you saying, okay, wait a minute, I'm going to have 12 here and 6 there, you can't just say 12 times 6. You have to think of how many rows are you going to have. Okay, you're going to have here, you're going to have 12. The second row, you're going to have another 12. And the third row, you're going to have another 12. So also, how many of the 12s can you actually fit in here? And that's the point I want to make. Well, if you have got something that is got 4 here and 4 that side, so I'm just going to, so this is 4 and 4 that side, and you can squeeze in, so you'll be squeezing in. Of course, we said you can have 12, so from here to there should be 12, but then you have that 12 taking, let's say that is 1, the height of one of them, so the height of one of those will be somewhere up there. Okay, so when you look at that, that means that this is already taking up, because the moment you put that thing, it has a diameter of 4 uh, in both directions, depending on how you put it. So it's going to be 4, and then of course there's going to be some space left. That's what I want trying to make here. So you can't just say here you're going to have 5. Okay, so I mean you're going to have 6. So I'm looking at this thing as saying, okay, wait a minute, if I was to input that, I'm going to have 5 over there, 6 over here, and 5 times 6, that will give you 1 row. So I'm going to look at the area. In fact, that is how one is supposed to approach this question. So let's just quickly go back. This question will have to look at the area. Remember that 72 that I'm talking about. So let's say the area of this flat surface here. And what is the area? Okay, I wasn't doing a particular good job. The area is 48 times 24. Okay, so let's look at the area. So you have got 48 times 24. Good. That's the area, 1152. That's the area here. That's the area. What is the area of one of this thing? The area of one of this thing, of course, the area of one of that, the area of that cylindrical, is pi r squared, which is pi, and r is 2, which is 4 pi, which we can then calculate. So if we say 11 divided by 4 shift pi, you'll see that I'm getting 91. So it means that in this area, 91 of them can be there. Okay, and so will the case be. So you have to think whenever you do this question so you don't do an obvious mistake. So the correct way of answering this question would not to do what I was doing here. You have to think of the area. So you take the area of the base, the area of one of that, and you divide it by 2. So it's about 91 that you're going to get. So this approach will definitely not work if you were to take that approach and you were to use it to say, okay, that justify me calculating the how many of those will be will fit in there. So let's just then take it step by step. So first we find how many cylindrical containers can be packed in the box. Well, we take the area of the box, the surface area of the box at the bottom, the area of the box where these things will obviously be standing. That was remember from what I've done over here, that was 48 times 24. So that's 48 times 24. we got 1152. Okay. Then we have the area of one cylindrical container. The area of one cylindrical, it was pi times 4 squared, not 4 but 2 rather, because the radius is 2. The radius of that is 2, which gives me 4 pi. So the number, the stuff that can be packed in will be 1152 divided by 4 pi. And we saw that we'll get about 91 of those containers. Right, the volume of the box. Now we already have worked it out before, but let's just see the volume is just multiplying all those dimensions with each other. The volume would be 48 times 24. See if I have got all those there, times 10 centimeters. Excuse me. Well, let's see what we get. 48 times 24 times 10. Of course, 11,510. 11,520, not in 10, in 20. This is the volume, and this is in cubic units. Find the volume of the empty space. Now, the volume of the empty space, when you, with the tubes, now here's the thing, the volume of one tube we did calculate. The volume of one is 125 and 5/7. And we know about 91 of them will be there. So if you take 11,520, the volume of the box, 11,520, minus 91 times the volume of 1, which is 125, the volume of 1 was 125, and 5/7. That should tell us more or less the amount of empty space that's going to be there. So grab your calculator again. So we take that 11,520, we say minus 91 times 125 and 5/7. Okay, right, these are more or less, so it's going to be about 80 cubic centimeters. That is going to be the amount of empty space that is there. Now they are saying calculate the surface area of the carton that was used to make the box. Now you can as well look at this thing as you can look at it as, let me just clean it up, so I want to bring it over. Just take a snapshot of it. The total surface area, I'm just going to paste it under here. So you're going to have two rectangles. There are many other formula, but for grade 9 level, I'm just going to go old school. You have two rectangles that you have to consider. You have got the total surface area. Okay, maybe I should just write a little bit to the left. You have the total surface area. That will be two rectangle of 48 times 24 plus two rectangles of 24 times 10. So the one at the bottom, the one at the side, and the one in front here to make 48 times 10. So if I had to highlight what I was now doing, this one here, 48 times 24, is the sort of the rectangle under here. There will be two of them. The other one is on top, as you can see. Okay. Then I'm going to change this color. This 24 times 10. Well, I'm just going to paint over it. That is this one over here. And the one on the side, the back there, that is where I'm saying there are two. So I'm going to find the areas of all of those rectangles and so on. And of course, the one in front, this one 48 times 10, that is this one over here in front. Okay, all the way the one in front, you get the idea. So there's going to be another one at the back as well. So that is what I mean when we do that. Okay, total surface area. So we're just going to find two of each of those rectangles. So 48 times 24 plus 24 times 10 plus 48 times 10. Okay, and hit enter. 3,744. Just make sure 48 times 10, 24 times 10, 140. Okay, 3,744. So that's 3,744 square centimeters. Right, we have got question 12. A rectangular piece of land is 57.6 meters long and 48.6 meters wide. They say you must find the perimeter. Now the perimeter is nothing but just adding all of those distances together. So this would be also 48.6. This one will also be 57.6 rather. Okay, so you're just gonna add them all up. So grab your calculator. You're gonna say 2 times, if you want to, 2 times 48.6 plus 57.6. Okay, 48.6, 57.6. What does that give you? 212.4. So that's 212.4 meters. How many fencing panels of width will be required to fence the piece of land? Now, what you're going to say is, you're going to say, okay, you want to put fencing poles, right? And you have a 1.8 meters between them. So if you take 48.6 and you divide by 1.8, okay, that should tell you how many should there be on the width. So 48.6 divided by 1.8, that tells you have got 27. So you'll have 27 over here. You'll have another 27 over there. Okay, right. 27 on the width. How many fencing panels of width? Okay, here on the 57.6 divided by 1.8 to see how many of them are we going to put in here, of course. So you're going to say, wait a minute, 57.6 divided by 1.8, 1.8, that gives you 32. So there will be 32 over here and same 32 over there, you know, of equal widths. Right, so how many of them will there be? So it's 32 times 2. Okay, I'll say 2 times 32 plus 2 times, what is it, 27. Okay, that should tell us the number of panels that will be installed there. Okay, so I can just go ahead and say, okay, 32 plus 27, that answer times 2. Good, 118 of them. So 118 panels. Okay. Right, question 13, give special name for shape A, B, C, D. Of course, again, it's just trapezium. Okay, the shaded area. Now, here's the nice thing about the shaded area. Has 2 marks. In order for you to find a shade, you're going to say half base times height. So if this whole distance is 8, okay, and this one is 4 as indicated there, then this one is also 4. And if this is 5, then this one is also 5. So the shaded area becomes a triangle. Area for half, base 5, and the height is 4. Okay, a half of 4, well, that's 5 times 20, half of 20 is 10. So this answer will just be 10 square centimeters. Right, we have got question 14. Now, how many, the diagram shows an empty scale, but you can see this is not, it has to be calibrated. It is not starting at 0, but it's really at 0.1 when there's nothing in here. So whatever you're going to find here, which is going to be 1.1234, that's like 1.4. In order for you to find the mass of the fish, you will be saying mass of fish is obviously 1.4 kilograms minus 0.1, because you started already at an error, so it's going to be 1.3 kilograms. So that's that calibration that you have to take in consideration. Right, when you look at question 15, a quarter of a liter, 1 liter is equal to 1000 milliliters, and 1/4 of that, okay, 1/4 of that, this is 250. Okay, so you have got 1000 divided by 4 is 250. So that's going to be like 250 milliliters. So this is 250 milliliters. Okay, this one has got 275 lemonade. So which cup X contains more lemonade? Okay, that is cup Y. All right, because that's got more. What is the difference between the two? So you take 275 minus 250. Of course, everything here is milliliters, and the answer is 25 milliliters. Good. Right, we have got question 16. A perimeter of rectangle is given by that formula. They say the length is 5 and the width of the breadth is 3. Calculate the perimeter. Now, perimeter is very straightforward. You just 2 times 5 plus 2 times 3. Okay? Or you add, that's 8, 8 times 2. 16 centimeters. Calculate, now they're giving you the breadth of a rectangle. They say the perimeter is 20. And the length is 8. And you have to find the breadth. Okay? Right, half of 20 is 10. 8 plus b, then b will be 10 take away 8. So b is nothing but 2 centimeters. You can play around with the formula, whichever method you choose. Calculate the area of the circle with radius of 5. Now again, the area is pi r square. Then for pi, we're going to use 22/7, and then for that, we're going to use 5 squared. Of course, you can use your calculator value, but I just want to keep the consistency going. So it's 22/7 times 5 squared. 5 squared is 25. Okay. All right. So I'm just going to leave my answer 78 and 4/7. 78 and 4/7. Anything that rounds to something that is making obviously sense, you can go ahead and do so. Right. Question 17. The diagram shows, let's just save up on this one again, The diagram shows a box in the shape of a cube. Now, this is very important to know that this distance all the way from there to there will also be 15 centimeters and so on. So the volume of the box would be 15 times 15 times 15 cubic centimeters. So this has to be cubic centimeters. 3,375. So just make sure of that answer. That will be 15 cubed, of course, 3,375. Write down the diameter of the tin. So the diameter of the tin will be half of that, which is 7.5 centimeters. Because the diameter is exactly the same as that length there. So this here is the diameter. So if they say, no, they say write down the diameter, my goodness. We have calculated the radius. So the diameter here, it's good that I've seen that, it's nothing but 15 centimeters. The height of the tin is the same thing. It will be 15. Okay. The distance. So the distance from here to there is the same distance from there to there. Okay. So it's also going to be 15. Just write down, there's no calculations, okay? So 15 centimeters. Volume of the tin is cylindrical. It's pi r squared times the height. The radius, now you have to be careful. The radius, yeah, very important. We did calculate the radius. The radius was 15 divided by 2. The radius is 7.5. So the volume would be 22/7 times 7.5 squared, and the height is 15. So let's just punch it in and see what is it that we're getting. 22/7 times 7.5 squared times 15, of course. Now it's giving us a rather 2,651. 2,651 and 11/14. Of course, anything that rounds to that, you can definitely give that answer. This answer is obviously being affected by whatever the radius value is that you are using. They say calculate the volume of space between the box and the tin. So we know the volume of the tin, we know the volume of the box. Of course, the volume of the box is that 3,300. We're just going to subtract the two. Volume of box minus volume of the tin gives you the empty space. So volume of box was 3,375 minus 2,651 and 11/14. We'll grab your calculator again. So you're going to say the volume of the box, which was 3,375 minus our previous answer. Of course, it's going to get 723 and 3/14. 723 and 3/14. Anything that is um, getting towards that, anything rounding to that. Okay, just saw the units here, so I'm just correcting as far as I can. Right, question 18, which I think is the last question. They say if the volume of a cylinder is 62.9 cubic centimeters and the height is 5 and the radius. Now volume of cylinder is pi r squared times height. What do they give us? They give us the volume, which is 62.9. Pi is 22/7. The radius is what we are looking for. R square is missing. And the height is 5. Alright, so we're just going to rearrange that left hand or right hand side. So I'm going to have 22/7. I'm going to multiply that by 5. See what answer do I get. 110/7. Okay, so it's 110/7 times r square is 62.9. So what I'm going to do is I'm going to say r square equals, that's 62.9. I'm going to multiply that by the reciprocal of this fraction. Okay, so I'm going to say, okay, 62.9 times the inverse of that fraction, which is 7/110. Okay, and that answer, well, I'm running out of space. Okay, so I'm just going to that answer that I have there, I'm going to write it here. I've got r square equals to, as I'll see, 4403 divided by 1100. Now to get my r, I must take the square root of that answer. Okay, so I'm going to say square root of that answer. Well, of course, 2.000 is about 2.0008 and so on. So the radius is about 2 centimeters. Got it? Right. So that question has obviously nothing to do with this one. So let me just take off the boundary. They are saying the total surface area of a cylinder. Now, here, this question here has to be done a little cautiously. You have to be a bit cautious. If you have to find the total surface area of a cylinder, maybe I need to append a page. So we just get to that. And we know what they are now here referring to is, according to right from the onset, the cylinder will be closed. So the total surface area of a cylinder will be, let's just append a page. Let's just append a page. Say, okay. Right, I'm going to append a page here. So what I'm going to look for is, I'm going to look for a cylinder in one of these questions that I have done. Okay, maybe even this one. Of course, this one has got a few things in it. See if there's any. Here we go. Right, so let's take this cylinder. Let's just go back and see if there's another one. Okay, that also has got its issues. Okay, let's take the one that we saw. Take a snapshot of this cylinder. Right, I'm going to use it here to explain a concept. So the concept that I'm going to explain is finding, this is this part 2, calculating total surface area of a cylinder. The TSA, total surface area of a cylinder. Now you have got a curve surface area we're going to call it CSA, which is this curved surface part here. And that one is calculated, So first of all, to find the area of a cylinder, the formula is pi r squared times h, where this is the h, okay, plus, now here's the thing, this one, the pi r squared, okay, you have to consider that there are two of them, okay. Now, the way this one is just one, it's open, okay. If I say find the surface area of a cylinder, you have got this circle, two of these circles to contend with. You have a circle here, you have another circle over there. Let me just bring it up. Now this circle, of course, it's a little bit smaller than that one. This would be that circle that is there. That's pi r squared. And there's another one, pi r squared. So there will be two of them. Okay. So to find the area, the area of a cylinder. The area of a cylinder is pi r squared times the height. So if you have to bring in a rectangle between the two, the rectangle is representing the part that I has referred to, pi r squared times the, okay, let me just bring in my pen over here, change the color. Okay, so here, let's say here is the cylinder, right? This cylinder, now this is the net. This here is pi r squared. This one here is pi r squared. Okay, this one here is the curved surface area. Now, there will be two of them. So there will be 2 pi r squares. You see what I mean? Plus the curved surface area. Now, the curved surface area is very important that we see. What is this distance of the curved surface area? Well, it's exactly the same distance over here. That is the circumference. Circumference. Good. So what is this distance here? Well, that's the height. So what is the formula for, so it is circumference times the height. So what is the formula of circumference? Circumference is 2 pi r times the height being that. So this will be 2 pi r times h. That's how you find the total surface area. Okay, so TSA, if I have to take out pi r as a common factor, I'll have r plus 2h plus r. Is it? Okay. Of course, you remember you have got 2 pi r squared, no? 2 pi r squared. So you can just as well, before I take out common factor, let me just simplify what I have. Of course, I could have. Oh my God. All right, so here we go again. So hopefully it can recover everything. Just stand by with me on this one. Just have to find that particular document. Of course, these are the type of things that do happen. Wonder how I have saved that one now. Okay, as we said, we are so close to the end, and I have this issue, mensuration. So just find it. See where I put that document because I can't seem to find it. Let's find its location. Let's hope it recovered. Okay, the info. We're very much close to the end. Let's restore. Let's save as well. Okay, it saved it. All right, now this is what I was referring to. So obviously I am busy with this stuff. Okay, so the TSA is 2 pi r squared because it's this one plus that one, plus the curved surface area, which is 2 pi r h. Okay, the circumference times the height. Now, if we take out, of course, the 2 pi r as a common factor, I'm going to have pi r plus h. In fact, you might have seen this formula somewhere else, and this is basically where it all comes from. So this formula is we're going to use this formula for a closed cylinder here. So if you want to find the total surface area, we're going to say the TSA is 2 pi r times r plus h. Then it's 2 times 22 over 7 times, what is the radius? Of course, the radius of the cylinder was 2. Then I have the radius, which is 2, plus what was the height? Just make sure that we use the right information. The radius is 7.5. Where did I get even 2? The radius is 7.5 and the height is 15. Okay. The radius is 7.5. Okay. No. We have calculated the radius of the cylinder. The radius of the cylinder, goodness gracious, this is a different question, Mr. Max. The radius is 2. The radius is 2. From that, what is the height? The height is 5. The height is 5. Okay. Right. Let's just grab a calculator and see what is it that we are going to get. So I nearly got confused there. See what this stress of this software does. Okay. 2 times 22 upon 7 times 2 times, in brackets I have 7 times 7, just 2 plus 7, okay, times 2 plus 7, okay, good. Anyway, the answer is 88. So this would be 88 centimeters square. And that is the total surface area of the cylinder. They say for the volume of the cylinder, if the volume of a cylinder is 300, so volume of cylinder is pi r square h. The volume of cylinder is 307.9, and then they say the radius of the cylinder is 3.5. So I can just go ahead and include that. That's pi times the radius, which is 3.5 squared, pi r squared times h. Then we know what the value of pi is. Of course, the value of pi is 22 upon 7. Then they say calculate the total surface area of the cylinder. So we need to find the height. So first find the height. So we can clean up this bit. Okay, save also. Okay, we clean up this bit. Okay, just let it do its own thing. Just want to finish. You have got 22 over 7. This is a different question, so it has nothing to do with that question, but we'll be using the same formula. Okay. If I calculate that part, I get 77 over 2. It's very important that this is 77 over 2 times h is equal to 307.9. This implies that h would be let's see, 307.9 times 2 over 77. Okay, just the inverse of that. The height is that horrible number, which I'm going to leave 300. The height is really, let's just capture the screen. All right, so that is our height. Right. Now, what are they asking? The volume of that? They want this total surface area. Now, we know from our work before that the total surface area is 2 pi r plus h. So it's 2 times 22 over 7 times our radius, which is 3.5. And then we have 3.5 plus our height, which we calculated, 3079 over 385. So we're gonna just punch all of this in on a calculator. That should give us our respective answer. Okay, so let's see where we are. 2 times 22 over 7 times 3.5. Okay, then in brackets you're gonna have 3.5 plus, of course, that total number 3079 upon 385. No, 385. Again, that's why I took the screenshot so I can see it. Okay, let's hit enter. Of course, we get another horrible number, which is, well, I can just as well round it. It's about 252.9. 252.9, more or less, give or take. That will be the total surface area. Now, granted, these questions are a little bit tricky for grade 9, and of course, it can also be used by learners in senior grades. We will not really ask such complicated questions. It might be that it was part of the old grade 9 syllabus, but I believe many of you can still benefit from them. It's just that I gave this as a worksheet of my learners, and I thought maybe I can just work it out and I can see how they will fare. Okay, so as we start a topic, I always like to give stuff through, let them have a go, and then I will be taking the topics as they come. Okay.